Alrighty, so this is question number 2 from the Chem 113 exam number 3, and it's asking what is the pH of 0.50 molarity solution of propanic acid C2H5OOH in water. The Ka value is 1.3 times 10 to the negative fifth. And so what we're going to want to do here is set up an equation right here. C2H5COOH plus H2O is going to give us C2H5COO minus plus H3O plus concentration. And we know that the pH is going to be equal to the H3O plus concentration. And so that's what we're going to want to solve for. And we're given the initial 0.50 molarity solution for propanic acid. And so what we're going to want to do is set up an ice table. And we know that 0.50, this is going to be negligible. And we know that we're going to start out with 0 amounts here. And so what we're going to do, minus x, because this is a one stoichiometry. This is also one stoichiometry 1, so this is plus x, and this is going to be plus x. And we know that from the, because this number is so small, that this number here is going to be the same. So it's just going to be equal to 0.50. And so now we have these three numbers at equilibrium, and we can set it equal to Ka, which is equal to 1.3 times 10 to the negative fifth. So what we're going to do, Ka to 1.3 is equal to H3O plus concentration and C2H5CO minus over okay, and so we're given this because we know that for the Ka that it's going to be the products over the reactants. We're already given the concentration of the reactant, which is going to be 0.5. And so we know that what we're going to want to do here is it's going to be x squared over 0.5 is going to be equal to 1.3 times 10 to the negative fifth. And so from here, we can solve for x, and we know that H3O plus concentration is going to be equal to C2H5COO minus. And so what we're going to want to do here is take 1.3 times 10 to the negative fifth, multiply it by 0.5, and then once we do that, all we have to do is take the square root of this number to get x. So we take the square root, and that's going to give us our H3O plus concentration, which is going to be equal to 0.002549. Well, now that we know the concentration here, we can solve for the pH. All we have to do is take the negative log of this answer, and that's going to give us a pH of 2.59. And therefore, if you look on the answer sheet, the answer is 2.6, and so what you're going to want to do here is simply round up, and that's going to be your pH of a 0.50 molarity solution of propanic acid.